Today's lesson is 8.8. Differences of squares. What does the word difference mean in math?
Subtraction.
Subtraction. Okay. So we're going to be looking at expressions and equations where we have the subtraction of squares. What are squares? Something, yeah, when something has been multiplied by itself, it's squared, right? So 4 squared is 16. 4 times 4 is 16. Okay, so we're looking at, that's all this means. We're looking at, they're going to end up, most of them being binomials that are differences of squares. So subtraction of two numbers that are squares. And we're going to factor them. We're also going to use them to solve equations. All right, we have learned how to multiply two binomials that look like this. We learned a little shortcut. We can FOIL it. FOILing will always work when we do this, but we also learned a little shortcut. Does anybody remember the shortcut? Nope. Okay, well let's FOIL it and then relearn the shortcut. So FOIL is x squared, and then outside would be minus 4x. Inside is plus 4x. And then last would be minus 16, right? Okay, so what happens when we have this to the two middle terms? The two middle terms drop out, so we end up with x squared minus 16. Okay, what we have here is a difference of squares because x has been squared, right? We have a difference, which is subtraction, and we have 4 squared. So this binomial is a difference of squares. Okay, and what we learned, the shortcut that we learned is that when you have this situation where you're multiplying these two factors, and the first term is the same, and the value of the last term is the same, but you have opposite signs, we learned that the middle terms will always drop out. So you square the first term minus square the second term. That's the way we stated it when we did that lesson. I think it was the 8.4 a couple weeks ago. So, squared the first term minus squared the second term. That's what we did. Okay, so now let's use that knowledge to factor a binomial that looks like this. So when we have a difference of squares, we have a first term that's been squared, we have a last term that's been squared with subtraction. What are the two factors going to look like? So we're going to look like w plus 6 and w minus 6. Does that make sense? If we FOILed this, we would square the first term to get w squared. We would square the last term to get minus 36. And the two middle terms will drop out. Okay? So we're going to factor the differences of squares. You have to take the square root of each term. What is the square root of 16h squared? 4h. And what is the square root of 9a squared? 3a. 3a. So we're going to have a 4h plus 3a and 4h minus 3a. What is the square root of 121? 11. So we have a plus, what's the square root of 4b squared? 2b. And we'll have 11 minus 2b. Nine plus c and 9 minus c. 64g squared. 8g plus h and 8g minus h. Those are the two factors. All right. Not too bad so far, right? All you have to do is take the square root of both terms of the binomial and then make one plus and one minus. All right, sometimes we have to do something in order to get a difference of squares. 27g cubed minus 3g is not a difference of squares, but we can make it a difference of squares if we factor something out first. So factor out what number will go into both of these. Three what? 3G. So if I do 3G, then I'll end up with 9, oops, that's supposed to be a G. 9G squared minus 1. Okay? So now I can do this. I can still factor 3G times, what's the square root of 9G squared? 3G plus 1 times 3G minus 1. Nope.
Or no, why?
We can factor a y out of this. So take a y out. So we've got y times negative 4y squared plus 9. So we would do y, and we would have a minus 2y plus 3 and a positive 2y plus 3. We've still got the plus and the minus going on. They're just in front of the first term instead of in front of the second term this time, right? So it doesn't matter what order they're in, as long as we have one of the terms as a plus and a minus. Okay? All right. We can still do a difference of squares here. So what is the square root of b to the 4th? B squared we'd have b squared plus 4 and b squared minus 4. Are we done? This will factor again, won't it? We would have b squared plus 4, which won't factor, I believe. And then b squared minus 4 is another difference of squares, right? So we'd have a b plus 4 and a b minus 4. Okay? Something real similar here. What's the square root of 625? 25. So we have 25 minus x squared times 25 plus x squared. Now we can factor this one again. So it's 5 plus x times 5 minus x times 25 plus x squared. All right. All right, now let's apply some different techniques to factor more complex polynomials. Once again, this is not a difference of squares as it is, but we can turn it into a difference of squares by factoring it. What? 3 what? Okay, I want to factor what number will go into both of these? 5x. So 5x, which would make that x to the 4th minus 9, right? Okay, so now I can factor this as a difference of squares, so it would be 5x times x squared plus 3 times x squared minus 3. Can I do anything else? Nope, that one's as far as I can take it. Because, I can't factor this one again because 3 is not a square number, is it? Alright. Ooh. I can do some factoring here.
7.
I can take a 7 out of all of these. So that gives me x cubed plus 3x squared minus x minus 3. All right. I can do some factoring by grouping. You remember doing that? We've done that before, factor by grouping. So I can regroup with, I'm gonna have to start using some brackets here. I can regroup with x cubed plus 3x squared minus x minus 3. Actually, that would be, if I pull out a negative sign out of all of that, that would make that x plus 3. So what can I factor out of this first group? X squared, right? X squared. So that would be x plus 3 minus, and it's okay to put there's a 1 here, right, that we can distribute because I want to have a coefficient there, and x plus 3. So when we do the factor by grouping, we're supposed to come up with this situation where we have 2 identical factors that we've pulled out, which we have, and now I can regroup in the middle. So it would be 7 times x squared minus 1 times x plus 3. And now I can refactor. Now I've got a difference of squares in the middle here that I can factor. So it's 7 times x plus 1, x minus 1, and x plus 3. Man, that was kind of scary, isn't it? A lot of steps to that one. You're gonna have to see a couple of steps in advance, see where you want to end up in order to know what steps to take along the way to get there. Since this is a lesson on factoring differences of squares, I knew that I had to get something that was a difference of squares in order to factor it, right? And so I had to take several steps to get here where I had a difference of squares to be able to factor it. All right, let's look at solving some equations involving differences of squares. These are going to be similar to what we've been doing. So what do I do first? Let's get the equation zeroed. So subtract 50x. So 18x cubed minus 50x equals 0. And all right, what can I factor out of it? 2x. So 2x, and that would be 9x squared minus 25 equals 0. Do my factor of squares, or difference of squares, sorry, so it's 22x times 3x plus 5 and 3x minus 5, right?
Yeah.
Now here's something that's a little bit different. Now, how many things do I have to solve here? I've got 3 different values, possible factors that could be 0, because any one of these could be 0 to 0 the equation. So I've got to solve all 3 of these. We're used to seeing them come up with 2 solutions, but there are times that they could come up with 3 solutions. So 2x equals 0, which means x equals 0, or 3x plus 5 equals 0. So 3x equals negative 5. So x equals negative 5/3. Or 3x minus 5 equals 0. So 3x equals 5, which means x equals 5/3. So x equals 0, comma, negative 5/3, comma, 5/3, or whatever order you put them in, I don't care. I think that's the first time we've seen one with 3 solutions, isn't it? Sometimes it happens. All right, let's factor differences of squares here. So 0 the equation. That would be x squared minus 9/16 equals 0. To factor, we're going to take out square roots, right? So what's the square root of x squared? X. So we're going to have an x plus and an x minus, right? What's the square root of 9/16? No. Don't make it harder than needs to be. What's the square root of 3? 9. What's the square root of 16?
4.
It's x plus 3/4 and x minus 3/4. 3/4 times 3/4. 3 times 3 is 9. 4 times 4 is 16. When you multiply fractions, you just multiply straight across. So that equals 0. So x equals negative 3/4, or it equals positive 3/4, right? You don't mind me skipping some steps there, do you? All right, factoring differences of squares. Here we go. What's the square root of 64x squared? 8x plus 1 and 8x, oops, forgot my 8. 8x minus 1. So 8x plus 1 equals 0. 8x equals negative 1. Divide 8. So x equals negative 1/8. And if we've got the same thing on this side, all it's going to be is a different sign, right? So it's going to be 8x equals, or x equals negative 1/8, or x equals positive 1/8.
If you see that, is it okay if we just skip this stuff?
I'm okay with that. If you've got, especially, yeah, I mean, if you solve for one of them, then the second one should just be the opposite sign. All right, so, oh, I didn't make an assignment slide, so it is 8-7 practice worksheet, or skills practice worksheet, I guess.